All right, we'll give it just a minute to get started. All right, looks like it's time to go now. So, hello everybody. My name is Canon Reeves. I am a roboticist and entrepreneur and maker in general. I've been building robots since I was 14, and I love everything about it. And in today's session, I'm going to talk about what goes into a robot and really what is a robot. Because robots can seem really complicated and intimidating, and at times they are. But if you look under the hood, there's a lot of logical systems going on that anybody can understand and learn. And so the purpose of today's video is to help you at a high level understand what goes on in a robot and how do you build your own robot. You don't need any supplies today. In 2 weeks, we're going to do a building session where we're going to build a zipline robot. And next week, we're going to be talking about how to design our own 3D printable robot pieces. But for this week, you don't need any physical parts to participate. So to start off, welcome to MakerCamp. If you want to continue to see more MakerCamp things, go to makercamp.com. And with that, let's just go ahead and get started. So to start, I'm going to ask a question. And if you could send it in the comments, send your answers in the comments, that'd be great. So what do you think is a robot? Like, how would you define a robot? Would you consider something like a drone to be a robot? Some people might, some people might not. There's robots that are kind of well known and common, like a robot arm, and it's kind of in the name, so it's definitely a robot. But there's some robots that might not seem like robots. So I will ask a few questions about. I will ask if a certain thing is a robot, and you tell me if you think it is. So to start, do you think that a drone is a robot? So I would say, yeah, we got a yes. I would agree with that. I think drones are robots. There are some drones that are kind of like maybe simple robots, but I would say at the end of the day, they're robots. And we'll talk about why in a minute. So next question. Do you think that a microwave is a robot? So I would say in general, a microwave is probably not a robot, but they're pretty close. So Jen says some people say no, some people say yes. Yeah. So let's talk about what makes a robot. Why would we consider something a robot? In general, a robot does three things, and these things can look kind of different, but in general, they do these same three things. So a robot can take inputs of some kind. It can make outputs, and it has some kind of decision or thought process. Thought is kind of a loaded word, not like thinking like we can, but there's some kind of computational process going on. So if we think about a drone is taking inputs from a few places. It's taking inputs from a controller. It's taking inputs from its onboard accelerometer and any sensors that it has. And it's also computing on its processor. And then finally, it's making outputs to its motors. So all of those things combined create something that can fly and do awesome things. But in general, that would be a robot. A microwave, however, does some of those things. So a microwave, it's definitely got inputs, kind of. It's got buttons that you could input. It does have a processor. Microwaves have a microcontroller. And it does have an output. It's microwaving things. But I would say that it is sort of like a dumb robot, enough so that I wouldn't consider it one, because it's not really monitoring like what it's microwaving. It doesn't know how hot things are. It doesn't really know what's going on. It's just taking a command and doing it blindly. So in general, I would not consider a microwave a robot, but I could see an argument if you do believe that. In reality, it can be kind of vague. And there are robots that do all kinds of things in every industry. There are robots that can perform surgery on humans. There are robots that are in space, on the International Space Station, everywhere, which I hope you all are tuning into the launch later. I think it's super exciting. So anyways, yeah, so robots in general do these three things of taking inputs, making decisions, and making outputs. And if you go a little bit below that and talk about like what is going on with each of those systems, oh yeah, so we got a question. What about Sophia? So Sophia, if for those of you who aren't familiar, it's a humanoid robot that made a lot of like press appearances. It is a robot in some senses. It's not as smart as they make it out to be. It's just got some basic kind of text-to-speech software in it, but I would consider it a robot. It's got really cool facial expressions. It's a neat experiment into what humanoid robots can look like. So anyways, so every robot is a intersection of three major kinds of engineering. And this is actually why I love robots so much, because I love engineering, and robots are like this awesome puzzle of three kinds of engineering. And those three kinds are software, electrical, and mechanical engineering. So the way these play together, well, actually, I'll just show you a robot and we'll talk from there. So this is what we call the base robot. It's a robot kit that my company makes. And what this robot does is it uses this ultrasonic sensor right here to tell the Arduino how far away something is and then drive accordingly. So I guess you can't really see the table, but I'll show you holding it in my hands. So if I plug this robot in, and you can see here the wheels are stationary. But if I put my hand in front of it, they will start moving. So if my hand is close, the wheels are moving in reverse. So the robot would be backing up on a table. If my hand is far away, they're going forward. And so it would be moving towards my hand. So the way this robot is working is it's taking that input from this sensor, it's processing that with this Arduino, and then it's sending the output through these motors, making it drive. So yeah, when it comes to designing something like that, let's look at just one part of the system in isolation. Let's look at what it means to take that input. So first, let's talk about what the sensor is. It is called an ultrasonic sensor. So here's one right here. So there are two eye-looking little things. Those are actually speakers and microphones. What happens is one of these emits a really, really high-frequency sound that we can't hear that travels along until it bounces and reflects off a surface. And then it travels back and is picked up by the microphone on the other sensor. This all happens extremely fast, and it uses the speed of sound to calculate how far away something is, which is phenomenally cool. So it is exactly like a bat. Yes, exactly, Asa. Which is pretty cool that we can create things that in a way mimic nature. Bats are, a lot more complex and they can do a lot better, but it's the fundamental way this works. You can actually find ultrasonic sensors on self-driving vehicles. So Teslas, for example, use cameras and ultrasonic sensors to build an understanding of the world around them, which at the end of the day is what taking inputs is for robots. It's building an understanding of the world, building a model of the world. Anyways, so this sensor is taking that value and it's sending it back to the Arduino. So to show you a little bit better about how this sensor works, I've got a little example. So this is using a microbit, an ultrasonic sensor, and a NeoPixel strip. So I'm going to just wrap this around me right here. I'm going to hold this up and turn it on. So we can see what those outputs look like in a sense. There are some sensors that can detect smell. It's kind of a complicated science, but there are certain things that you can sense. The reason being, smell is really just tiny particles of things floating. And if you can sense those particles, you can smell. It's definitely not as accurate as like humans are, but it's cool. Anyway, so you see this light. Basically, as I move my hand, the light will move as well and come around me. And if I move quickly, it reacts really quickly, because what's happening is this is processing things at such a quick speed that it's able to keep up with that. So we have our sensor. We're using this ultrasonic sensor. There's a few considerations we have to make when it comes to incorporating it into a robot. The first is the power level. how much power does this take? There's two things we really care about here. It's the voltage and the amperage, but primarily the voltage. So this is a 5-volt sensor. Most of the electronics you deal with at the hobby level will be either 3.3 volts or 5 volts. So in the case of the Arduino, which I'll grab one and show you, everything is 5 volts. So our robots, like this one right here, runs off 5 volts. And yeah, here's the Arduino. Really cool stuff. And let me grab a battery. Actually, oh wait. Anyway, so first consideration is what's the voltage? And what you need to do is match up that the sensor you're using has the same power level as the microcontroller. So we know the sensor. Let's talk about microcontrollers. So this right here is called a BBC microbit. It's a really popular microcontroller right now. It's got a lot of options for programming. This right here is an Arduino Uno, like we talked about earlier. Arduino has been a mainstay in the hobbyist community for over a decade at this point, I'm sure. It's really nice because there's tons of online resources for how to work with it, and getting started is just super simple. So these are two microcontrollers that I'd mainly consider when it comes to doing a project. Another one would be the Raspberry Pi. I'm trying to see if I have one around me. This is also my work desk. So I have just components scattered everywhere. So the third consideration would be a Raspberry Pi when you're considering a project. And a case where you'd use a Raspberry Pi is when your robot is like maybe communicating with the internet or using a camera, doing things that are typically a little bit more computationally intensive. I'm not from Princeton. I actually am a senior in computer science at the University of Arkansas. I learned a lot of this actually online. A lot of this, what's so cool and empowering about the internet and this kind of hobbyist stuff is that you can learn any of this online. There's so many open tutorials. It's awesome. Anyway, so the Raspberry Pi is kind of like a tiny computer. Yes, you do use Raspberry Pi for complex sensors. So for example, if you were going to use a LiDAR, so this is what's called a LiDAR. And a LiDAR works by spinning the surface around really, really, really quickly. And if you see these two holes, it actually works kind of similar to the ultrasonic sensor. So what's happening here is one of these, I think it's this one, is emitting what's essentially a laser, not on the visible spectrum, so you won't see it. And the other one is picking up those photons when they bounce back. And so it's doing this so quickly that it's like building a map around itself of the world of how far away things are. So it can't see in 3D, it just sees in 2D. But you can use that for a lot of like navigational stuff. So this is something that you would see on your Roomba, for example. You can also find these in self-driving vehicles. A lot of self-driving vehicles use LiDAR. So yeah, so Raspberry Pi, great for complex sensors. It is a little bit more work sometimes to get involved with, or to get started with a Raspberry Pi. Most of the time I would recommend people starting with Arduino or Microbit if they're just trying to get quickly going. As far as online communication, so anything programming it online can at some point be hacked. Nothing is truly secure. But I would say for most projects that we're going to be doing, you're going to be fine. There's a few best practices. I'm honestly not well qualified enough to speak on what would be the best practices for setting up something that's communicating online. But for the most part, if you're just doing something like a home weather station, you're going to be fine following tutorials. So Raspberry Pis can be plenty safe. Let's see the next comments. So we have a comment about, would it be possible to design a sensor for a certain chemical that can be released into the air and pick that up? Is it possible? Yeah, absolutely. I'm not a chemist. I'm not great with biology and these things. I like things like robots that aren't alive because they're less confusing to me. But you know, if you want to get into sensor design, spend some time reading Adafruit and SparkFun's tutorials. So Adafruit and SparkFun are amazing companies that put a lot of effort into their documentation. And they don't only, they will give you tutorials for how to use the sensor you buy from them, but they'll also go further and talk about how it works. So if you're interested in like sensor design things, try looking up smell sensors, and especially on SparkFun and Adafruit, and seeing what their tutorials say about those. So I got a little bit sidetracked, but that's okay. We're going to get back on. So we were talking about microcontrollers. So for this robot that we're building here, let's talk about the Arduino and how we want to power it. So in general, the Arduino runs off of 5 volts, but when you plug in a battery, you need a little bit more than 5 volts. So let me see if this battery is charged. Hey Rex, can you give me a battery? So the Arduino runs off of 5 volts, and when you plug it into your computer, it supplies it with 5 volts. But when you plug into this barrel jack, typically you're going to need above 6.5 volts. So if I plug in this battery, which is 12 volts, it actually works. So how does it do that, right? This is 12 volts and this is 5 volts. That's kind of weird. What's happening is the Arduinos have what's called a linear regulator. And this is getting really in the weeds, so you don't have to worry too much about remembering the names. It just has something that converts that 12 volts to 5 volts for it to use. So when you're selecting sensors, we're going to start with, what's my sensor? What am I trying to sense? What's its power level? And what microcontroller can it work with? So in this case, it works with the Arduino. So then we say, okay, how do I get my power? And I would start with batteries. I like to use 12-volt batteries. You can find a lot of them online, but you can also find some 5-volt batteries. Just be careful, because when you are putting 5 volts into an Arduino, you have to put it right into the 5-volt line. If you put anything under 6.5 volts into the barrel jack connector, it'll actually reduce the voltage to under 5 volts, maybe closer to 4.3. So we've got our battery, we've got our sensor, we've got our microcontroller. What's next in our system? Well, the outputs. In this case, it's going to be motors. So motors are a really, really interesting thing. Hey Rex, can you do me a favor? Can you grab a motor and some jumper cables? So yeah, let's talk about motors, because these are really common in anything you make, really. So it's kind of cool to understand what goes into them. So there's a few different kinds of motors. So for the most part, what I like to work with, DC motors. They're just going to be like these yellow ones right here. The next one, someone in the comments got it, servos. So servos are also really cool. They're a little bit different than the motors because they can track position. So with a DC motor, I'll show as soon as Rex brings that over. So DC motor, the way that it works, let's see. There we go. Thank you, Rex. So here's a DC motor. This is just a little yellow one. Let's see, I probably have a wheel or something I can put on it. Yeah, here we go. So we've got a little wheel. So here's our motor, and if we want it to turn, there are only 3 ways to control this motor. We can either turn it all the way on, turn it all the way off, or run it in reverse all the way. So let me show what that looks like. So here I have my Arduino. I'm going to plug one of these wires into ground on the Arduino, and I'll show you all the wiring in just a second. And I'm going to plug the other one into VN, which is 12 volts. And you can see the motor's running. All I did was just plug it into power. There's no programming involved so far. It's just plugging it in. And I'm going to unplug those. And I'm going to ask in the comments, what do you think will happen when I switch the wires? So ground goes into power, and the one that was in power goes into ground. I'll give you all a second to guess that while I wire it up. It will turn the other direction, exactly. So here it is right now. And I don't know, it might be moving a little bit too fast to tell, but it's moving in the other direction. So DC motors, well, okay, yeah, let's think about this. Let's keep going. If I can only turn it all the way on or all the way off, how do we have robots that are able to precisely move and turn? How are they able to like navigate through things? And the answer is kind of interesting. It works actually the same way as LED lights do. If you don't know how LED lights work, basically what it is they turn on and off really, really quickly. And what happens is our eyes can't really perceive that they're turning off and on so quickly, so we just think it's on, and that's a way to save power. Motors do the same thing. When you're driving a motor, a DC motor, it basically turns the power on and on and off so that it goes to the speed you want. So if you wanted it to go full speed, you would connect the power 100% of the time. But if you wanted it to go half speed, you would only connect the power 50% of the time. So you're turning it on and on and off. And you need special boards to help you do this. So what we use is our motor controller around Rex. Thank you. So we use what's called a motor shield. So this is a motor shield from Adafruit that you can stack on top of your Arduino, and it will allow you to control motors precisely. So if you're wanting to add motors to your project, you're going to need your microcontroller, you're going to need your battery, I would advise sensors, your motors, and then you're also going to need a motor shield. So we've pretty much come up with all of the electronics that go on in this robot, right? So we've talked about our sensor. Oh, there it is, our ultrasonic sensor. We've talked about our Arduino and motor shield, and here's some wires connecting those. We've talked about our battery, and we've talked about our motors. So let's talk about the last piece that ties this all together, and that is the structure, the actual physical parts that allow our robot to move. So when you're building a project, this is one of the concepts and parts of the project that can be really tough because it can be hard to make physical things that are accurate. So one of the coolest technologies I think to come around in the past 10 years, really come to popularity, is 3D printers. You'll notice some behind me. 3D printers are so amazing for making robots because, if you're not using 3D printed stuff, you're often using like manufactured metal parts, which are awesome and they have their place, but it can be really tough and there's a really high barrier to entry to making things out of metal. But 3D printers make it where anybody can create something online or create something on their computer and turn that something into a real physical part in a relatively seamless way. And so the hard thing about 3D printing, though, is learning how to design your own 3D printed parts. So I've been designing and 3D printing robots for like a while now, and it takes a lot of getting used to. You have to think about a lot of things like how the part prints, where you want your motors to lie, and like how to incorporate the sensor and how to mount the brain, and like if you mess one thing up, you have to like reprint it, and it just kind of becomes it's a little bit tough starting out. So about 2 years ago, some friends and I started a robotics company called More Technologies. And what we make is this 3D printable robot ecosystem. So think of it kind of like Lego, but for 3D printing and robots and prototyping. So it starts with this really simple part. It uses these little things we call end connectors and wooden dowels, and they just snap together. And these can be made on any 3D printer with no supports. So it starts with this just little brick, but then it expands further. So you can take several of those and stack them up into something more complex, or you can build things like this robot we built. And what we do is we take the simple components and standardize them. So like when you've got a motor, well, we already have motor mounts for it, and it's just quick and easy to snap things on. Same thing with sensors and frames. So to show you a cool little thing out that you can make out of the platform, this is called the Games Kit. So this is a little retro Game Boy that Rex over here, who's been helping me, primarily designed. So if you see, you can play Brick Breaker. So it's kind of hard to see, but all of this was programmed on the Arduino, and it allows you to build your own controller and learn about how all these different components work. So you're actually building and wiring together a joystick as well as buttons and a screen, and you can build this however you want. So you can just build all kinds of things, even drones like we showed earlier. So In the next week, what we're going to be talking about is how to design your own 3D printed parts that actually work with this ecosystem. The way that we designed it is if you were able to design a rectangle in CAD. CAD is an online tool for designing 3D printable parts and part files. If you can design a rectangle in one of those programs, you can design parts that work with this. So you can build a really simple robot like this and then start to add onto it. You could add an arm. You could add new sensors. You could add mounts that allow you to add a LiDAR and have it act like a self-driving car, all kinds of things. And what's cool about this is we've got an online community where we're sharing these part files. So you can work together and share and build this really cool thing that comes out. So the joystick, that's a great question. Let's see if I have one over. So I've got the joystick. Rex, is there a potentiometer nearby? Oh, I got one right here. So the way the joystick works. So this is what's called a potentiometer. I don't know if you can see it in focus, but what it does is when you turn this little knob right here, it changes the resistance. So the resistance, we won't get into all of that, but what you need to know is that the Arduino can read that resistance value. Thank you. And so the way a joystick works is it's actually just two of these potentiometers stacked up to each other. So if you look right there on the side, let's see, there it is. That's potentiometer and that's potentiometer. So when I rotate it this way, it's only moving this potentiometer. So it's as if this was right here and this was what was being rotated. So basically that Arduino is taking in the values from those two potentiometers, and from that it can know where it's pointing. And so that's the same technology that's in any video game controller. The potentiometers are used all over. So they're a cool thing to learn about and to work with. So let's see. Anyways, next week. So next week we are going to be talking about designing parts in Onshape, which is a CAD platform. Our company is called More Technologies, so there should be a link in the description to our website, as well as you can find this robot on MakerShed. And actually, we'll be using this kit in 2 weeks. So if you want to participate in 2 weeks and build along, I'd recommend going ahead and getting this so we can build with it. So in 2 weeks, we're going to be turning this robot into this robot. And this robot is a zipline robot that can travel back and forth. And I actually have a zipline that I usually have set up on my chair. So it sits right behind me. Yeah, go ahead. But unfortunately, it broke right before we got on the live stream, which is very unfortunate. Yeah, so this was on my chair, but now it's not. So it will be in 2 weeks. And in 2 weeks' time, we're going to be discussing how to build this. And we're also going to be next week, we're going to be talking about how to design parts for that. So we're going to design a mount for your phone. So you could, in theory, 3D print this phone mount, put it on this zipline robot, and have it position itself to take your picture, which I think is really cool. So we're going to be doing that in 2 weeks, or next week. Next week, we're going to be designing parts, and then the week after that, we're going to be building this robot. So make sure you tune in. And also, if you go to makercamp.com/events, you can find all these in advance, so you can make sure you're there. As far as videos go, so I do have a YouTube video channel, barely. It's got a little bit of stuff on there. I will share with you all a link to where you can find all of our tutorials, part files, and other cool stuff that we make. So this link I just sent in the chat is MakerPlace. And MakerPlace is where we share all of our tutorials and things. So I'll go ahead and show you guys my MakerPlace. Let me pull it up real quick. So this is MakerPlace. And this is where you can find all of the tutorials and files for our robots. So here we've got some tutorials on the base robot. We've also got some on Onshape and Tinkercad. So I would recommend going and checking that out whenever you are ready to start building your robots. So let's see. I think that covers a lot of it. Are there any other questions before we hop off? Let me see one thing real quick. So it looks like you don't have any questions. Okay, so just kind of in closing, as you go, make sure if you do end up getting this robot and if you end up building things, please post and tag at Family Maker Camp and hashtag Make Together as you make things. If you ever have any ideas or have any questions about robotics, please, you're welcome to email me, canon@moretech.co. You're also welcome to come to our website and you can chat with us there. Oh yes, let me type out my email. Do I have anything about Actobotics? Actobotics. What, if you mean like robots that can perform? Oh, Active. Okay, I see what you're saying. That's the company. No, I don't have anything with or about them. I haven't ever worked with that before. But you're welcome to email me any questions that you have. I really like this stuff, if you couldn't tell, and I'm always happy to help people out. So yeah, and also Maker Camp is really awesome for allowing me to come here and talk. I'll be back next week and the week after. If you would like to support Maker Camp, please go to make.co and consider subscribing. Make is an amazing company, and I love everything about what they do and who they are. It very aligns with what our company wants to do and how we view the world and what we want to do to impact it. So yeah, please go support them. Thank you all for watching. I hope you all enjoyed it and learned something, and hopefully I will see you all next week. So thank you.